unquenchable thirst for space exploration and pushing the boundaries of science will see us going deeper into our solar system and beyond for as long as humanity exists. Space agencies of different countries have made remarkable progress in their respective areas. There have been unimaginable developments in the field of space because of such space agencies. Though there is a bunch of space agencies in the world, but there are few who always remains in the headlines, and that is because of their work and inventions. Each of them provides launch services, that is, builds their own orbital class rockets, builds their own satellites and scientific payloads, and has either achieved human spaceflight or interplanetary robotic science missions or both. Few of the agencies that we will be discussing in this video are NASA, that is National Aeronautics and Space Administration, ISRO, that is the Indian Space Research Organization, ROSCOS, that is Russian Federal Space Agency, CNSA, that is China National Space Administration, ESA, that is European Space Agency. ISRO is known for shocking the rest of the world with brilliant accomplishments on a Spartan budget, successfully sending a probe of their own design and manufacture to Mars on their own rocket and on their very first attempt, and successfully testing a scaled prototype of their own space shuttle. ISRO will launch country's second space telescope, X-ray Polymetry Satellite, that is XPOSat, which will be smaller in size and specialized. Launching on a PSLV rocket in 2021, XPOSat will study the polarization of X-rays emitted by cosmic objects from Earth orbit. Last year, ISRO called for instrument proposals for a Venus orbiter mission, Shukran, to be launched in 2025. This is somehow great because Venus lost all the focus when Mars started getting all the attention. Right now, there is only one spacecraft at Venus, the Japanese orbiter Akatsuki, compared to 8 at Mars and 3 more on its way. So, ISRO sending a mission to Venus should be refreshing for the global planetary science community. The primary scientific objectives of Shukran include studies of Venus' surface and subsurface, its atmospheric chemistry and solar wind interaction with the planet. Another mission in ISRO's pipeline include a follow-up of the Mars orbiter mission in 2024. Now let's talk about the plans of another well-known space agency, that is NASA. It is known for constantly wanting to be on the cutting edge of technology and also of mission planning. NASA is going to launch ASTROS, that is Astrophysics Stratospheric Telescope, for high spectral resolution observations at sub-millimeter wavelengths. It is tentatively scheduled to launch in December 2023 from NASA's Long Duration Balloon Camp near McMurdo Station in Antarctica. ASTROS is a high-altitude balloon mission for studying astrophysical phenomena. One of ASTROS' main science goal is to provide new information about stellar feedback in the Milky Way and other galaxies, a process in which stars either accelerate or decelerate the formation of new stars in their galaxy. Next is Interplanetary Nano Spacecraft Pathfinder in Relevant Environment, that is INSPIRE. This project will demonstrate the revolutionary capability of deep space CubeSats by placing a nano spacecraft in Earth escape orbit. Prior to any inclusion on larger planetary missions, CubeSats must demonstrate that they can operate, communicate, and be navigated far from Earth. These are the primary objectives of INSPIRE. Next in the row is ROSCOS. It is known for dominating the first 2/3 of the space race of the 1950s and 60s and for their no-frills reliability in human space flight. Russia's Roscosmos space agency aims to launch the Luna 25 moon lander in October 2021. The Russian instruments are meant to research the composition, structure, and physico-mechanical properties of lunar polar regolith, dust, and plasma exosphere around the moon's south pole. To date, no spacecraft have been to this region, which is eyed by many nations as a site for future moon bases. The project is being implemented at the request of the Russian Academy of Sciences, part of the Federal Space Program of 2016 to 2025, and is financed by Roscosmos. Next in the row is ESA. It is known for its expertise in international and interagency cooperation. European Space Agency is going to launch JUICE. It is the first European mission to Jupiter. It is going to launch in 2022. Its objective is to collect detailed observations of Jupiter and 3 of its largest moons, Ganymede, Callisto, and Europa. When the explorer arrives in the Jovian system in 2030, its main focus is to understand the conditions that might have led to habitable environments on Jupiter's satellites, particularly on Ganymede. Another one is LISA, that is Laser Interferometer Space Antenna. This will launch in 2034. LISA aims to detect and measure gravitational waves produced by compact binary systems and mergers of supermassive black holes. LISA mission will use 3 satellites precisely measured around 25 million km apart that will be able to detect much fainter gravitational waves with signals smaller than 20 picometers, that is tinier than an atom, over a million kilometers. From this, we will be able to determine more about the nature and location of black holes. Now let's talk about another famous space agency, that is CNSA. It is known for building its own human space flight program without the help from the Americans or the Russians. China has a mission operating on the far side of the moon and is preparing to launch another this year to collect lunar samples. Chang'e 6, a backup mission for this year's sample return launch, is scheduled to head to the moon in 2023 or 2024. Chang'e 7 is planned to launch around 2024 with the dual aims of landing on the south pole of the moon and closely studying the region from orbit. The CNSA Lunar Exploration and Space Engineering Center last month opened a competitive call to relevant institutes to develop payloads for the 5 different spacecraft involved in the Chang'e 7 mission. Chang'e 7 will also pave the way for Chang'e 8, another lunar South Pole landing mission planned for the late 2020s. To meet its extended goals of permanent human presence on the moon and constructing SBSP satellites in LEO by 2025 and in GEO by 2030, China is developing the Long March 9 to be flight tested in 2030. The Long March 9 Super Heavy Lift Carrier rocket will be capable of lifting 140 metric tons of payload into a low Earth orbit or a 50-ton spacecraft to a lunar transfer orbit. Now let's see what do we explore in the next few decades about space. Let's hope for the best.